All right, hello everyone. Thanks for joining us for today's webinar about declarative pipelines with Jenkins. To get started, I just want to let you know a few things up top. One, we are recording, so if you need to leave early or maybe you have a colleague who is unable to join, they will be able to view this later on. Two, we are going to be able to take questions at the end. We should have a fair amount of time for questions, so please, as soon as you think of something, go right ahead and ask it. Even if you think maybe we'll get to it during the presentation, we'd rather you ask so we know what people want to learn more about than not ask at all. There's also going to be a very short survey at the very end, just asking what you thought and what you'd like to learn more about. Beyond that, I'm going to introduce our speakers in just a moment. And for anyone who is attending DevOps World in Lisbon coming up in about 2 weeks, you'll be able to meet myself, Mark, and KK all at the event and ask whatever kind of questions you want about this in person. So once we get started, I'll be posting a registration link as well as a discount code for everyone who maybe hasn't registered yet at this time. Without further ado, though, I'd like to get us started. So I'd like to introduce someone to get us to really kick it off, and I think everyone here is going to know him. Kosuke Kawaguchi, the Jenkins creator. KK, why don't you get us started?
Hey, all right. So good morning. Well, I guess the good morning, good afternoon, everyone. So today, we have two excellent speakers, the Mark and Tyler. This is one of the things I'm very proud of about Cloudbees is we have such a deep bench. People who've been perhaps drinking too much Jenkins out of the water hose for day in day out. So today they're going to talk about the next slide, please. So today they're going to talk about the Jenkins declarative pipeline. So let's move on to the next slide as well. And then just a little bit about myself. So I created Jenkins at this point. It's like 15 years ago. I've been forever with Cloudbees, and I have I'm responsible for a lot of things in Jenkins, a lot of problems in Jenkins, including the originally what became the Jenkins pipeline. So I wanted to tell you a little bit of story from there to kind of kick us off. The next slide. So I still remember the week where I got into the room with Jesse Glick in Los Altos Cloudbees office to start writing what eventually became the Jenkins pipeline. At the foundational level, at the plumbing level, Jenkins pipeline was built as the DSL, the domain specific language, on top of a general purpose programming language. So what's good about it is it gave people quite a bit of power. But at the same time, over the time, we came to realize that we didn't guide people well enough. So too many people are failing to tame it properly. So it was just too wild in the eyes of too many people. So next slide. So we came to realize that we wanted to give our users something that's more tamed, more delightful, like easy to handle and adapt and so on. And then the key, I think, is in layering. In other words, if you look at the things that we deal with, like a CPU, well, at certain level, it is running assembly language, but that doesn't mean like you program in those, right? So it's the same idea. So we wanted to create more, sometimes we call it the lit path, but the guided way of helping people use Jenkins pipeline, and that became the declarative pipeline. And it's been I think it's been so many years since we've been doing it, but we constantly keep getting surprised about just how people don't know that they have these wonderful things in their toolbox that they use every day in day out, and then that's going to make them so much more productive and faster. So that's, I believe, is the story of today. So on that note, let me hand it back to Mark, I think.
Thanks, KK. Thanks so much. I agree with KK. Pipelines are easy to create and easy to extend. And sometimes we've discovered that our users of Jenkins just aren't aware of how simple it really is to use Jenkins pipelines, in particularly Jenkins Declarative Pipelines. We're going to show you today some of the simplicity, some of the elegance, some of the ease that there is in you working with Jenkins pipelines. Declarative pipelines with Jenkins. So it's all about how do we make it easy. So Jenkins has been used for a very, very long time to create and deliver great software. And it started with the concept of freestyle jobs and grew to add multiple freestyle jobs and even matrix jobs so that we could evaluate many different combinations, and we would string things together. We would combine one thing to follow on to the next thing, to the next thing. And it ended up that we were creating something that was quite brittle by having these chains of jobs strung together. Well, pipeline is a better way. There is a better way to do software delivery with Jenkins. And so I'm going to do a first preliminary part and show how we'll create a skeleton declarative pipeline using the Jenkins Blue Ocean interface. It will let us define the process simply and clearly, store the definition right with the software development, and see it all from the UI. After creating the skeleton, I'm going to show you how to build and test with it. So do real build, real test. And then we're going to add test reporting to it, and that will help us keep it simple so that we build like developers do and test like developers do. So let's switch, and we're going to go to a real Jenkins system. So here is my Jenkins environment. It looks like the Jenkins user interface because this is Jenkins. And I'm going to open up the Jenkins Blue Ocean interface. Blue Ocean is provided by a Jenkins plugin. If you don't have it, you can install it easily from the Update Center. You'll notice here that the first thing that Blue Ocean says is, don't have any pipelines. Would you like to create a new pipeline? So I'm going to do that. I'm going to create a new pipeline. Now, Blue Ocean already presents these 5 different choices of ways that I could use to store my code. In my particular case, I'm going to use Git. I've actually got readily accessible to me a copy of Gitty, a free Git server that provides all sorts of capabilities. And so I'm going to copy this URL to my Git server. Here you'll see what you see in this is a simple Java application. Notice that it's got a POM file, so it must be Maven. It's got some source, it's got some tests, and it's got a small directory of build scripts that we use for it. So I'm going to paste that repository URL there, and I'm going to click Create Pipeline. Notice that I haven't opened up my text editor. I haven't done anything beyond simple clicks on the UI. So the pipeline will begin creating. Now let's take a look inside this repository, what's happening. So this is a repository with source code. Inside the source, there is the source of the application itself, and there are tests as well here in the source/test directory. And I've got some build scripts in it. Now, if we check this out, we should see that Jenkins has, it tells me right here, notice there, no Jenkins files were found in this repository, and it offers to let me create one. Here I have a nice interactive UI from the Blue Ocean interface. I'm going to create a new stage. This stage, we're going to call it build. And in that, I'm going to create a skeleton entry, which is just to print the message building. Now, why do a skeleton? Why not do the real thing? Because a skeleton lets me visualize very rapidly if my pipeline is doing what I want. So we're going to say building. We're going to create a stage for test, and we're going to do the same thing, print a message, testing. Again, the same thing for deploy, and we're going to print a message, deploying. Well, that was a pretty simple thing to do. I've now got a three-stage pipeline, build, test, and deploy. Pretty common things that happen in a software development process. I'm going to click the Save button here to store that directly back to my Git repository. Add a skeleton pipeline. Save it and run. Blue Ocean writes the file, transmits it back to the Git server, and now we're going to go back to our Git server, refresh this page, and there's the Jenkins file. Now, I didn't enter any curly braces, I didn't do any logic, I didn't do anything more than something that is every bit as easy as what originally attracted me to Jenkins the ability to configure entirely from my web browser. Notice that here's a stage named build, here's a stage named test, and here's a stage named deploy. And there are my little simple skeleton statements inside. Now let's go back and see how Jenkins is doing. And what do you know? We've got a build that's run. It ran through the 3 steps: build, test, and deploy. It was that simple and that easy. Now we can expand these and look and see, oh wow, there's my message that was output. Okay, that's great, but that's really just a skeleton. Okay, let's go to the next level. Let's really build some code. So I'm going to go back to my editor. In the build stage, I'm going to leave in that step, and I'm going to add one more step. Now, it just so happens that I have a script in this directory called Jenkins/build.sh. This is whatever the build script developers would usually use in their normal environment. It's not something special or specific. It could be Maven, it could be Ant, it could be a call to make. Whatever your developers typically do, that's what should be put here. We intentionally do that thing so that we know we're building and testing the way developers build and test. So there's that one. Now we're going to, I happen to also have a script that calls Jenkins/build-test-all/test-all.sh. And we've got deploy, where we say, let's run a script, Jenkins/deploy.sh. So I've now switched from using a pure skeleton to using something that will really perform operations. So when I save this, it's going to run this job. It's going to invoke Maven, compile the code, test the code, and take, now I admit the deploy step, I've made a dummy, but the others are real. So let's do a save and add build, test, and deploy script calls. Again, this will go right to my repository. We'll be able to go look in the Git repository and see just how it went. So notice it's already started the build. And if I refresh this page, let's go back up to the top level, look at Jenkins file. And there's the build script call, there's the test call, there's the deploy call. It was that easy. Now, if we want to watch what's happening, let's look at what happened in the build process. So I invoked the build script, and here is a whole bunch of, now those of you who are Maven users will recognize this. It looks like this downloaded roughly half the internet in order to build this trivial little Maven project. And that's very much the way it feels, and it shows me the reality of what it did. It downloaded all those things and is running them. Now we've got tests that ran, and here the tests show us it ran a test, no failures, no errors, and none skipped. And it ran my little deploy step. Now the deploy, I admit it, is just a dummy. It says deploying and does nothing. It was that easy to go from a skeleton to actually building, testing, and deploying. Now, one of the niceties that Blue Ocean offers is across the top here, it will tell us the things that, some other things that are going on, like for instance, the changes that occurred. So here we see the last change that it recorded was that I added build, test, and deploy scripts. But what about my tests? Oh, no tests archived, because I need to add one more step to record and display the test results. So I'm going to do that. In my test step, I need to add another step, and sometimes I have difficulty remembering these things, so I'm going to just use the word test, and there it found the correct step. I'm going to click this button to add a JUnit formatted test result display, and I happen to know that my test results are in the target directory, and I never remember how to spell the whole surefire thing, so we're just going to say star.xml and get everything that are XML files there. So now I've got print my message, run all my tests, and JUnit formatted test results. Let's save it. And now, so now record test results. When I click the save button and run, it will launch off and run it again. So let's go back and look in our Git process, our Git server, and let's see what we've got. There it is. It's recording those, ready to record those results, ready to show them to others. Now this will take a little bit because it's still got to run things. So the running will happen, it'll continue building, and we'll be able to see test results shortly. The idea here is that we want to keep it simple. We really like the notion that simplicity is all about building like the developer builds, use the same commands, get the same results, test like the developer tests, same commands, same results, and do it all from the user interface. It's intended to be that simple, make it that easy to understand. Let's look at that result and see how it's doing. So we ran our tests, they all passed. We look at the tests and it says, yep, all the tests are passing. So I've completed my piece. Tyler, you want to take it from here?
Yeah, I think that'd be a great idea. Thank you, Mark. And a quick question, I think, for folks that are currently using freestyle jobs, Mark. I've heard a lot about pipelines. Is it really this easy just to download the Blue Ocean plugin and bring my repo? Is there anything else or a gotcha that I'm missing?
There really aren't more gotchas. Thanks to Jenkins' own dependency management, when you choose to download the Blue Ocean plugin, it will download the plugins that it needs. It will make itself available to you, and you can just run. So it works great. Now, there are certainly plenty of optional additions that they may find helpful and useful, but exploring Blue Ocean is just as simple as we've shown so far.
Awesome. And then is there a reason that I hear so much about pipelines over freestyle jobs? Because I've been using Jenkins for a while and freestyle jobs seem to meet my needs today, but I hear a lot about pipelines. Why should I migrate towards pipelines?
Well, for me at least, pipelines have been a real positive because now instead of storing the representation of my build process in Jenkins' own configuration files, I'm storing the representation of my build process right in my source control system. So we talk about doing things as code, and in this case, pipeline as code means that my Git repository has right inside of it the definition of exactly how I build my software, including the Jenkins job that does the build. So for me, that is a very attractive piece of what pipeline can do for us.
Makes a lot of sense. Thanks, Mark. So I think what Mark has shown us to this point is a really skeletal view of a pipeline, and then we've added some mud to the frame, so we're actually doing some real world tasks. But oftentimes, that's not going to be the complexity of my pipeline. It's not that simple. I'm going to need more complex operations to fit my actual development needs. So what I'm going to cover is going to be adding parallel tasks so that you're not running tasks only in sequence. That way you can optimize your builds. There's also a way to follow your branching strategies and add conditional statements. That way, there's only execution of some stages based on the branch on which it's being run from. That way, you can collaborate with other developers. And then lastly, we'll also add a timeout to some of our test stages as well. That way, we can avoid, hung test results or errors that might lead to misleading failures, rather than just sitting there endlessly waiting for an execution to conclude. We can now add a timeout. That way we know that our test should only live for a certain amount of time in our pipeline. So the first thing that I'm going to do when we go back into Blue Ocean is we're going to add a multitude of tests. I'll add a smoke test for integration and performance testing as well. We'll also add a conditional to the deployment step. That way it will only execute when we run that specific pull request or that new execution of our pipeline on the master branch. This will also cause us to add a development branch directly from the Blue Ocean UI as well. And then lastly, I'm going to add a time limitation for one of our testing stages. That way I can determine whether or not it's going to fall within the expected amount of time when it comes to execution. So what this allows us to do is keep it simple, and it's easy to maintain all of my different tasks. It's easy to incorporate multiple different development teams because we don't develop as an individual. We really do have an organizational need to cooperate within our build tasks. And additionally, it allows me to segregate the duties. I may not want a developer to run an end-to-end task and deploy to production every time. Instead, I might want them to be able to build and test their microservice or artifact before someone like a QA manager or a release engineer, which will be played by Mark in this example, then they can run the deployment to any environment that we deem necessary. So I'll dive back into the Blue Ocean editor. You'll notice that I can already see the pipeline that Mark has created. I'm actually going to create another pipeline, and I know we're using Gitty for this example, but I would also like to highlight what it looks like to run tests in sequence rather than just parallel, so we can get a comparison between execution time, and we can see how we can optimize our actual pipeline execution. So for this, I'll just add my GitHub token. You'll notice that we're also highlighting that GitHub is a free solution as well. You can use Git, GitHub, Bitbucket, GitHub Enterprise, and Bitbucket paid version. So it's really an extensible tool as well. You can see it is now logged into which organization I want to use for my specific Jenkins file. For the case of this webinar, I've actually already created this Jenkins file, and it is an exact replica of what we're going to be creating with our parallel stages. And from this terminal, it will create this pipeline for me. So just for an idea of exactly what it's pulling from, this is the GitHub page. This is the Jenkins file, and this is the exact same pipeline that Mark created previously. You'll notice that I've actually added a couple of test stages, which we'll add in our parallel steps within Blue Ocean. So you'll notice that this will be exactly the same execution that we're going to run from the Blue Ocean editor as well. And it is already executing. So it's loading in the test scripts that Mark already outlined. So we can see our JUnit tests as well from this tab. And then it'll also add our performance and integration testing stages as well. So as this loads, it's important to note that this allows me to use multiple different editors, because not every organization is going to be standardized on a single editing platform. This allows your developers to have the freedom to use a tool that they're most comfortable with as well. You'll see now we have executed our test stage, our integration test, and then in the performance, I have a sweep command, and it's followed by a timeout as well, so that we know it'll execute within that allotted amount of time. So as this runs, I will go back to my pipeline editor. And you will see now I have two different pipelines. So I will go into the exact example that Mark had created earlier. And from this page, I'm now going to add those specific test stages in parallel rather than in sequence, like I just showed you from our GitHub example. So I'm going to add this, and I'm going to call it the integration testing or integration tests. And we'll add a step. We'll do a simple print message, and we'll say integration testing. And then I will add an additional step as well. And this one is going to allow us to add a timeout for our performance testing. So in order to add a timeout, it's actually going to be a wrapper around a specific step that we're going to enable. So I'm going to set this for 90 seconds. Remember, you want to give yourself plenty of buffer so you don't get any misleading errors should the timeout come across before your execution is actually completed for that test. So I will add a child step. In this case, I will just add performance testing complete. And now I have a fully functioning test stage as well. All right. So from here, now I've taken the sequential test stages and I have now put them in parallel so that we can optimize our build processes. So I will save this, and I will save it directly to the master, and I will say added parallel.
So you're going to put it on, wait a second, you're going to put it on the master branch, Tyler?
I am, and then I'm going to add a specific branch for our deployment as well. So first of all, we're going to test this versus our example in GitHub, and then we're going to add a conditional to the deploy stage. That way we can get a comparison between the two, and we can add branch conditionals at the same time. So we will run this specific example, and you'll notice that now if I navigate back to Git, it will update with our new Jenkins file. And you will see it's actually added the parallel syntax, and it has multiple different test stages that are now within that specific phase of our CI/CD pipeline.
So that Jenkins file is still editable by human beings if they want to bring up their, in my case, I love my Emacs, so I could edit it other places. I don't just have to edit in Jenkins. Nice.
Absolutely. This gives you that principle of running it as code, right, Mark? That's what you mentioned before. Not only can you create this simply in the UI, but now we can also store our pipeline syntax as code, so we get all the benefits of running it in the solution like Git or GitHub as well. So as this executes, I would like to navigate back to the original pipeline that we created, and that was in GitHub. So you'll notice the execution time. It ran for 1 minute and 24 seconds. And this is our sequential testing with a deploy step that runs as well. It'd be interesting to see, wouldn't you agree, Mark, that we can optimize this by running these specific tests in parallel?
Well, and okay, I'm amazed because let's see what the parallel results do. I am curious because this is a single hardware execution unit. I would be surprised if parallel benefited it very much. Did it actually help?
It still will affect it, actually, since it is still running on the same execution node. It will still result in some benefits as well. So you can imagine by running steps in parallel, even for builds that might run for a longer execution time, let's say 30 minutes or an hour, you'll see even greater results as well. And once again, this is the exact same Jenkins file that lives in Git that lives also in GitHub. So these are exact same replicas so that we can get an accurate comparison. So as this executes, we'll see that it has now completed. I will navigate back to the window, and this is run in 50 seconds. So we can see that is roughly 35 seconds or so of saved time by running these steps in parallel. And if you were to leverage that across, let's say, a 30-minute build cycle or a pipeline, you're now saving almost, what is that, 12 or 13 minutes of execution time. So you can really optimize your CI/CD builds.
Well, and okay, so I assume that those nodes that are in the test that are running in parallel, if we had multiple agents, it could have actually run on multiple agents and multiple executors. Whereas with sequential execution, it doesn't matter. We're stuck waiting for things to finish.
Absolutely. Imagine if you ran this on specific build nodes and build agents. Imagine how fast this would actually execute at that level as well. We'd see even greater returns when it comes to optimizing our build patterns. So from here, what we've done is we've added some test stages in parallel, but we still have a deployment stage that is running on any commit to both master and any other branch at this point. And we don't have another branch in Git yet at this level. So what we'd like to do is add a conditional statement. And you'll notice that I'm going to navigate directly into the pipeline editor. There is not currently a way to add this using the GUI editor directly in Blue Ocean, but what I can do from the deploy stage, I want to define this as running only on the master branch. What does this allow me to do? It allows me to separate two uniquely different kinds of users. That way my developer, when they want to execute this pipeline, they are only running builds and tests. They're not having to deploy this to a staging or pre-production environment every time they want to iterate a certain change. And also, it also locks down my ability to not merge it to the master branch. Instead, only folks like Mark, who may be my release manager or my QA manager, have those privileges so that developers aren't running end-to-end deployments with each execution of their CI pipeline. So from here, I will add a when conditional. So it's just a when curly bracket, and then I will space over and I will add branch is master. So this means that this executional statement in the stage of deploy will only run when I commit this directly to the master branch. So I'll update that and I will save. And this time what I'm going to do is I'm actually going to create a new branch. I'm going to add an annotation in here for a comment and say add conditional statement for execution on master branch deploy. So now what I'm able to do is I'm able to save and execute this pipeline directly from the Blue Ocean editor. And what it will do in Git, it will actually go in and create this development branch within my source code repository. And you'll see that it will actually skip our deployment stage because it is not being executed directly on the master branch.
So you've introduced this concept that we deploy only from master. So who or what are some of the cases where you might find that? Can you describe those a little more?
Absolutely. Let's think for an example for a lot of feature-based development companies. I want to deploy a new feature, but I don't want to test it directly on my production instance or even want to deploy it maybe to staging or a QA environment. Instead, I can spin off a feature branch off of my main master branch. I can employ that new code, that new feature that I want to test, and I can run it as a separate Jenkins job from the same repository, and I can test it as a developer before it gets promoted to let's say a QA environment. That way I have the freedom as a developer to have my own pipeline in the same repo. I can follow that feature branch strategy.
Nice. So I get the benefit then as a developer that I can merge from master to my feature branch. I can use it, and those merges from feature branch keep me current, and then I can propose things back to others that merge into master to go to production. I like that. Very nice.
Absolutely. Now I can collaborate with my other developers. I can spin off my own feature branch. I can create these while other developers can also leverage branches that they can use to build their own features as well. So now we're really developing as a team, and we can just merge these back to our master or our single source of truth for our application code. So as we look, I just executed it on the development branch, and you'll notice that, wow, it didn't meet our conditional when statement. The deploy will not occur, but at the same time, all of our tests have run. So you'll notice in Git, it has actually created that development branch directly for me, and the Jenkins file is updated with the conditional to match only on the master statement. So from here, I have completed all of my work. I've introduced, in theory, a new feature or a new branch, and now the project would be handed back over to someone like Mark, so that what they can do is now merge this into the master branch and have the execution to deploy this to whichever environment that we'd like to.
Thanks, Tyler. That's cool.
So Mark, if you can take it away from here.
Yeah, let's see. Now I've got to take sharing. Max, do you give me sharing?
Sorry about that. Should be.
There we go. And I click the show my screen button. And now if we're lucky, do you see the Git page? Tyler, am I showing the correct thing? Oh, yep. No, let's see. Show. Yeah. Okay, good. So this is what Tyler just committed, right? Here's his Jenkins file that he committed, all those things that he just did. I can see those same things here inside the Jenkins server. It's all visible. There it is happening. If I look at all the pipelines, I see his Blue Ocean pipeline, all visible to me. We're working on the same Jenkins instance. It's a good thing. So what's the next is you may have a pipeline that is more complex than what we've described. And that's perfectly fair and reasonable to say, hey, my pipeline is more complex than what you've shown. I've got teams, but for instance, I have a process that may require that we release only with official permission from someone who must grant that permission. The Blue Ocean system has the ability to wait for input. You may say, oh, there are things I need to do. I need to publish results of a build to an artifact repository. Yep, post-processing steps. You may even have places where you say things sometimes can be disposed of because I don't need to run them. And we've got a concept of milestones. Let's talk about all of those. So I'll show you how to define wait for input to prompt for input before executing a step. This allows interactive approvals. So if your organization needs official approval from a person before they're willing to deploy to production, wait for input is the solution. We'll show how to do that. Post-processing steps let us choose to do things after all the other things have occurred in a step. This one, you'll just need to look online to see how to use it. And milestones likewise. Milestones let us skip steps if a later job had already reached that step. So for instance, imagine that you're running 5 or 6 builds in parallel, and one of them completes tests for a later version of the repository. Milestones let you say earlier jobs don't need to waste the time running those tests again. So milestones, and let's take a look at see how that input works. So I'm going to go back to pipeline demo. And I think we should switch development models. So I'm going to do my work on the development branch. And here, I'm going to edit this pipeline. And what it's going to do is bring up the editor for me. As it brings up the editor, Chrome is not happy. Come on, Chrome. There we go. As it brings up the editor in the deploy step, I'm going to add, or the deploy stage, I'm going to add one more step. And again, because I'm lazy, I'm going to look for the wait for interactive input step. The message will be, shall we deploy? And on the OK button, we want to say yes. Okay, so
Mark, answer
this.
me this.
Yes, Tyler.
This makes sense at this point, but I thought DevOps was all about automating this process. Why would I want to have an interactive input? This seems to slow down the process.
That's a valid question. And the reality, at least for me, was that there are plenty of organizations where they're on a journey to implement DevOps. They really are. They're on a continuous improvement journey. But the place they're at right now is they need official approval before they release something. And this lets them implement what they have right now, not just the eventual destination where they will get to a point somewhere in the future where they do continuous delivery, where every commit to the master branch delivers to production. But for right now, they may not be there. And this wait for interactive input allows them to insert real steps that will help them get their work done while they're on their journey towards continuous delivery. Now I've got to move this one up because these steps execute in sequence. I need to move it up to the top. So it's going to wait for interactive input. Steps been added. Let's save that and off we go. So wait for confirmation before deploying. And we're going to save that and it will get started and run. So now we can go back into my repository and see that, yes, here is the wait for input. It will appear down at the bottom. This is, you'll notice this is getting a little bit, oops, yeah, there it is right there, the input message. This is getting interesting. There are a bunch of steps hiding in here that are doing build, test, parallel testing in various forms, conditional deployment, and deploy only after someone has confirmed, yes, they want to deploy. That input step can actually be further constrained to say there are only specific individuals who are allowed to answer the question. So there are all sorts of marvelous ways that you can use input to get things done in your organization. So let's look at this one. So here's my deployment, and it's setting here. Did I miss not getting my wait for confirmation before deploy? Oh no, oops. I am sorry. Guess what? I did a marvelous thing. I deployed to exactly the deploy branch, which completely, or to the development branch, which skipped my step. I got to merge this. Hang on just a minute. Let's do the merge. Max, I assume we've got a few more minutes, so I'm going to go ahead and do this. If this is not okay, you let me know, and I will suspend and we can go to questions. I'd like to show this piece before we get into questions.
Absolutely. Let's finish this up.
I think this is a great example as well, though, Mark, because they're not going to add this directly to the master branch anyways when they want to try some executional status. So we're going to add this to the development branch before we ever merge it to master. We're not going to make any edits ideally directly on master. It's all going to come through pull requests. So this really showcases best development practices anyways.
It does. Thanks very much. You make it sound like that was an intentional thing. I like that. That's very kind of you. So Gitty will let me merge this to the master branch. So I'm going to merge it, and off we go. Okay, the pull request has been merged. Now when I go over here to my pipeline demo, you'll actually see that Jenkins was informed by Gitty, and can also be informed by GitHub and by Bitbucket, that it should launch the build automatically. So my act of committing that pull request caused the master branch to automatically build. And here it is, it's going to run, and we'll have a little bit of time for it to run. As it's running, we can take a look at how it looks on the master branch just to see that, yes, this Jenkins file really now includes building, testing, integration and performance tests, a deploy, and the conditional input on the master branch. And now if we're lucky, we should hear, yes, there it is. It's asking me the question, do I want to deploy? So I can click the yes button, and it will go on and do the deploy. That gives you some hints about the real capabilities that are already built into your Jenkins server, ready for you to get good things done. What we've shown you are components that are available for your use, no charge. I love free. It's amazing what we can do with Jenkins, what we can do with Gitty, what we can do with public accounts on GitHub and Bitbucket, all sorts of things to make our jobs easier as we're developing software. Now,
so Mark, I have a question. I have a question for you, if you don't mind.
Sure.
I noticed that you have to be on that terminal for me to approve that. Let's say you are the release engineer and you need to approve it. Are you expected to sit there and wait all day until that input step comes up for you to promote this to deployment?
That's a good question. So input steps can certainly be made to timeout. So I can hold for that, but ultimately this job will in fact sit and wait until someone approves it. It will not deploy without approval unless I put a timeout on my input step and say I want to pass even if it timed out. Was that what you were asking, Tyler?
Yeah, I think that's a good point. And also, what if I want to email this to an approver? Is that possible within this as well?
I think it is. Now that's one where I'd have to look at it. Maybe you need to answer that one because I don't recall.
Yeah, I think you can. You can say a build is waiting at this specific URL to a QA approver based on an email message, a Slack send, any of your instant messaging services. And that's a good point to add here. That way you're not constantly waiting for this to kind of come up and you're not monitoring the Blue Ocean portal. This allows you to have instant messaging.
I'm not restricted to notification of the pending request to deploy only from the web UI. I could do it through Slack, email, the other notifications. Thanks. Good clarity. Excellent. So Max, I think we're at a point where we should entertain questions if there are any.
Yeah, we got plenty here to go over.
Okay, go for it.
You already touched on this at the end, but one that came up a few times, just if we could reiterate. What you were showing everyone today, was this only for CloudBees customers or was this open source material?
So everything we showed today was strictly Jenkins. Now, we use the CloudBees Jenkins distribution because it's available to everyone for free, but it is the same in Jenkins. So Blue Ocean, all of the parts and pieces we did are absolutely available. Anyone using Jenkins anytime. Likewise, actually, I'm kind of proud of this. The Gitty server that we used is also free. And GitHub and Bitbucket provide free public accounts as well. So we truly showed every component of today's demonstration was free.
Yep, the GitHub pipeline that I created with the tests and sequence, that is also a public and free GitHub repository as well. Nothing you saw today was a paid for solution.
All right. Just going through all these, seeing what we can really get to. So how about this? Will Blue Ocean automatically decide the OS for you? So like if they want to write the pipeline for Windows Batch instead of Shell, or are they able to configure that on their own?
So it will not auto decide in that sense. What you do is you open up the jobs definition, and in it, instead of, so if my build needed to run on Windows, I could declare that I want this to be on a Windows agent, and then instead of a shell step, I would add a batch step. So I would add a Windows batch script instead of a shell script. So they have to intentionally choose which one they want to do, but it's easy to do. I do it all the time. And in fact, we build plugins on ci.jenkins.io using exactly that technique, where we build on both Windows and on Linux. Did that answer the question, Max, do you think?
Oh, I believe so, but I should say, if we get to your question and you don't feel it's answered, please feel free to follow up again. Also, as we're answering these, you can continue to ask what you think of. We're probably not going to have time for everything, but we will be able to get to people offline. There's also some similar questions I'm going to try to condense into a one-size-fits-all kind of question and answer, but if I don't manage, like I said, just re-ask it or let me know what didn't come up. And a few things, we've been getting questions the whole time, so some things have come up in the presentation, but I'm going to ask them anyway to retouch on them. So let's do, how about this one next? What about declarative forcing the jobs to run on the master and not run on the build agents?
So now I've got to be sure I understand the question. So I'm going to make some guesses on the question. So the steps, the groovy code, which is at the back end, the domain-specific language which is at the back end, in general executes on the master. However, the build steps themselves, for instance, the build.sh that I ran and the test_all.sh, those run on agents. So knowing where things run, declarative is really a good choice, specifically because it is strongly biased towards putting the vast majority of the work onto agents, not onto the master. Now, there are steps that do have to execute on master, but in general, we like what declarative does, and it's actually far preferred over some other pipeline solutions, which tend to be heavier weight on the master than declarative is. Now, Tyler, do you think I described that okay, or is there something that we need to clarify there to give a better answer on that question?
No, absolutely. And I think a good example of something like that is sometimes you might be building legacy applications that might not be supported by the Jenkins master itself. Let's say a legacy version of JDK where you're running builds that's not supported. It's important that you bring a build agent to the table that might have that installed on it. That way you can run those builds on the agent rather than the master. That's just the best practice moving forward. And honestly, another topic in general, but we want to leverage agents to its most capacity rather than running builds directly on the master itself.
Right, very good advice. In fact, it's distinctly, I consider it an anti-pattern. We should not run builds on the master if at all possible. It should be rare. Now, many people say, hey, the master's all I have. Consider adding agents, and in particular, agents can give you multi-platform and faster execution by giving you the ability to parallelize onto multiple pieces of hardware.
All right, thanks for that. Let's go on to this next one here. So this is a question referring to working within the Jenkins file directly. Is there a way to define Jenkins plugin dependencies such that my builder either fails or installs the plugin at runtime?
There isn't a way to do runtime plugin installation, and I think that's actually intentional, because plugins are part of the system-wide configuration. And so if you require a plugin, and if your Jenkins file requires a plugin, for instance, you use some exotic thing and you're referencing it in your Jenkins file, that Jenkins file will fail at execution runtime because it won't be able to resolve that plugin component. There isn't really a way to cause it to install the plugin. And given that plugin installation is a system level permission, that's a good thing. We wouldn't want pipeline scripts to be able to make system level changes. They should just execute builds and tests.
Is that said, think the idea of allowing Jenkins file to declare what it needs and then making it fail in more easy to understandable way, that's something we've talked about forever. So I don't know if that capability exists or not, but I'd love to see that if that doesn't exist.
Good point. So some sort of a scan the file in advance, look at it and decide, oh, we need these things fail early rather than waiting until execution or late stage execution to fail. Good insight.
Yeah, I think that is the half of the question, if I understand it correctly. To declare the intent more clearly, like what this Jenkins file needs or shared library.
All right. Let's do this one next. So if I have multiple Git repositories that need pipelines, can I put all of my Jenkins files in a separate Git repository? And what are the pros and cons of this approach?
Good question. So yeah, I had a yes, and the simple answer is yes, you can. But then the pros and cons question is a very fun and interesting question, because on the one hand, it's very healthy for developers to be able to see and modify the way their software is built. So that lobbies put the Jenkins file inside the repository of the thing that's being built. However, if you are a multi-repository solution, that may not be possible. Or if you haven't yet persuaded your organization that they should adopt the Jenkins file approach, you may need to create a separate repository and put the Jenkins file in it. That Jenkins file can, in fact, then clone multiple other repositories into its single working space. So that's actually one very attractive capability of Pipeline, is that it lets you choose how many repositories you'd like to use and how you'd like to use them. Now, admittedly, I think that's a relatively advanced use model. A multi-repository working environment tends to be complex and tends to cause a class of mistakes that developers sometimes dislike. But it is a perfectly valid use model and it can work quite well.
Yeah, and I think I'll add, when Jenkins detects a pipeline itself, it's just matching on a marker file for the syntax Jenkins file in that repository. So what we showcased today by leveraging multiple different branches within a repo allows you to have different Jenkins files still within that repository. So at the Jenkins level, it really thinks that there's completely different jobs, even though it's in the same repo, which wouldn't be possible if you're just using one branch.
Right, and I like Tyler's point. Multiple independent branches inside a single repo is not only accepted, but it's quite comfortable and can be done very well. So one example, Tyler or Max, to your question, would be that kind of model could be represented by independent branches which don't merge with one another but are still in a single repository, or they could use separate repositories.
All right, next one here. So for using Jenkins, should I install it locally or are there cloud solutions available?
There are certainly cloud solutions available, and where you install it locally or in the cloud is your choice, right? It's your call. You've got the flexibility to do it. Let's see, Jenkins runs either locally on your hardware, Windows, Linux, FreeBSD, Mac OS. It runs on my Raspberry Pi. It also runs in the cloud at AWS, Google Cloud, Azure, all sorts of other cloud hosting providers. So you choose, it can run any of those places.
All right, great. Is it possible to modify existing Jenkins file with the Blue Ocean editor?
It is, so long as you're using Declarative Pipeline, and the Blue Ocean editor, Tyler showed it to us briefly. You get to it by pressing Control S, and there it is. Now, I confess, I'm an Emacs user. I love my editor, so this is not a world-class editor that's here, but it does the job.
Yeah, and Mark, could you navigate to the Blue Ocean pipeline that we imported? That's a good example. That is actually a pipeline that we imported directly from my GitHub organization. And right now, Mark could edit that directly in the Blue Ocean editor.
Yeah, very good. I like that. Let's go find Blue Ocean here. And if I hit the edit key there, Now, if I do Control S, and that's all I did was Control S on my keyboard, and here it is ready to edit. Hope that answered the question, Max.
I believe so. Once again, just ask us if it didn't, or let us know if it didn't, excuse me. So this next one here, so when you have tests running in parallel, will they run in the same slave or different slaves? And if it's an option, how do you configure it?
So the agent that's to be used to execute can be selected by label. And Jenkins has a scheduling system that decides which agent should be used for what. The simplest way to spread things around is to use agent labels to allow it to spread. If you've got multiple agents, it will tend to distribute the work onto those multiple agents. So I'm not sure I answered that question, because that one I think maybe need more sophisticated discussion than I'm especially ready to give here. Yes, it absolutely will execute on any one of several agents that are attached. It chooses the agent based on labels that I can assign in the job definition in the Jenkins file.
All right, I see a perfect follow-up question to that. Before I get to it, I just want to let everyone know we're not going to have time to get to everything. We only have about 3 minutes left. I'm going to put my email into the chat here so you can reach out to me directly if you have more questions. I can get you in touch with who you need to be put in touch with. And also, we will be following up on these anyway. So by all means, you can send me an email, or we will be contacting you soon. But for this next one, can you give a quick overview of agents and nodes?
Sure. So agents are used by Jenkins to perform its work, right? What they are, think of it as capabilities or executors. And agents can be labeled. A label assigned to an agent is usually used to express that it has a particular capability. In my environment, for instance, I label things by operating system. So some of my agents have the label Debian. Others have the label Ubuntu, others CentOS, others Windows. I further, in my environment, label them with the version number of the operating system, just in case I have some tests which need to know about the specific operating system version. And there are actually plugins that will automate the management of those labels for you. So the other use of labels for me is to express a particular capability on an agent. For instance, if I need Maven, the label Maven is usually assigned to that agent so that I can just say, I need to execute on an agent which has the name, and let's put it here, Maven. And this would express saying, I want to do a Maven-based build on a Linux computer which has at least Git 2.20 on it. Did that answer the question, Max?
I believe so, and we'll get a follow-up if it didn't.
All right.
So for this next one, we are currently sharing Groovy files of our stages using the Jenkins shared library concept. What is the best way to share pipeline code among various pipelines?
I like pipeline shared libraries a lot. The story for me that was most delightful on that was I maintained the Jenkins Git plugin during my nights and weekends, and some very smart group of people created a pipeline shared library that made it so that I call one statement, build plugin, and a few parameters, and it builds on Windows, it builds on Linux, it uses the current Java, the current platform version, and it uses newer versions of Jenkins, all automatically, and they knew all sorts of things to do that I didn't have to worry about. I love Jenkins pipeline shared libraries. Absolutely, they're a great choice.
Exactly, and I think not everyone's as passionate about Jenkins as KK, Mark, and I are. So they're not always going to want to learn Jenkins syntax themselves. What it allows you to do is with shared libraries, almost share Jenkins as a service for some of those end users. They no longer have to go in and create these individual steps. Instead, you can provide them to them out of the box.
Thank you, Max.
All right, so we're at the top of the hour. I want to just get through one more question real quick to be respectful of everyone's time. Just to reiterate one final time to everyone, we were recording, so we'll be sending the recording out to everyone. We can include the slides with that. At the very end of this, a very short survey is going to pop up just asking what you thought, what you'd like to learn more about in the future. I have put my email into the chat for everyone. If we did not get to your question, you want to ask me directly. And beyond that, let's do one more question and maybe a couple of quick closing statements. So which do you think is the better practice? Having Jenkins file within the code base or have one Jenkins file for all the apps?
For me, I like Jenkins file in the code base. I think developers should have as much control as possible of their own build systems. However, I know there are cases and there are organizations where they intentionally choose something different. I prefer Jenkins file in the code base because that's been my experience. It just works better for me to have direct control. I also understand that that's not always the right solution for every business in every way they do software delivery.
I'll second that as well. As we move towards microservices, it's really important that developers have that ability to kick off their own builds from their code bases specifically. It lets them iterate more quickly.
I think actually the answer is both. You do want, well, in order, especially in say the microservices world in any bigger enterprise, like you gain the benefit of scale by lots of people, lots of teams like doing the same build and pipeline. Like to our earlier conversation, like we don't want people to be doing unique Snowflake if you have like 100 microservices. So the shared library, we have tools and like an abstraction to cater to those things like shared libraries. And then that way we can keep the presence of those like a CI/CD system in the repository minimum. So for example, I mean, we didn't talk about this today, but in your product, I believe we used to have this markup file, custom markup file. I guess that's a feature. So you can actually look for patterns, presence of the files and so on in the repository to automatically apply certain pre-baked, the pipeline. So that to me is like a best of both worlds.
All right. Thanks, KK. Yep.
All right. We're a little bit after the hour, so to be respectful of everyone's time, I think we're going to sign off for today. Before we do, Mark, Tyler, KK, do any of you any final comments you'd like to leave us with?
All right. Thanks for doing this, Max. Thanks very much for letting us present. Privilege.
Yes, thank you very much, everyone.
Yep. Thank you.
All right. Thanks, everyone. That survey is about to pop up, and we look forward to seeing you again real soon.